their practices are chill. Like they never go full
Your
pads.
next class
The most they go is just shoulder pads.
I think your next class
You still
will be about
A lot of them were in
Like
there
on their
before
video
you know.
footage,
Got everybody.
Okay,
Okay, guys, so let's do the easiest lesson of the year. All right, so this lesson is about matrices. Okay, so this is an example of a matrix. And what is a matrix? A matrix is an array of values. Could be variables, could be numbers, usually numbers, arranged in, that word looks misspelled, is it? Arranged? You know how when you just write something and it looks weird? In rows and columns. Did y'all share one? There we go. Okay, and they are usually enclosed in these little squared off brackets. So I'm going to put just like A, B, C, D, something like that. Okay, which way does a row go? Left to right. And then a column is up and down. The way you can remember that is, you know, columns that hold up a building or a porch on a building. Hopefully they're up and down, right? Or else they aren't doing their job. So columns are up and down or vertical. Rows are horizontal. Okay, so elements are the individual values. Remember I said it's an array of values. So individual values within the matrix. Element A sub xy is used to denote each element where x is the row number and y is the column number where the element is located. Okay, so it's kind of like a GPS of a item in a matrix. Okay, so for example, let's look at this matrix here. How many rows does this matrix have? 3 rows. How many columns? 5. Okay, and when we have that situation, we always put rows by columns. Okay, and my personal way to remember which one comes first, and it will be yours now too, Robin Campbell taught you this. Rows come first, then columns. I have met students who were in colleges that I remembered Robin Campbell, rows by columns. So if this has 3 rows like you told me, I would say it is a 3 by, and how many columns? 5 matrix. 3 by 5. So that's always rows first and then columns. This one up here was a what by what? 2 by 3. Okay, so that's how we identify the dimensions of the matrix. Okay, so now, if I have A sub 25, that's not a 25, that's an A sub second row, 5th column. So X is always the row, rows comes first, Y's come second. Okay, so this is saying identify what's in the second row, 5th column. Okay, go to the second row over 1, 2, 3, 4, 5. That would be the -2. So it's kind of like an identifier of location, a GPS. Okay, let's just go down. So we'll go to number 3 next. So what is in the first row, 2nd column? First row, 2nd column would be a 40. Okay, this means first row, 5th column. So here's your first row up there on the top. First, second, third, fourth, 5th column would be a 21. Okay, fill in those next 3 and we'll check them real quick. A31, A34, A22. Okay, so what is A31? What'd you get? 5. What is A34? 52. And A22? 32. Okay, any questions on that? Casey? You're good? Okay. All right, so for these, we're just going to state the dimensions. So if I'm asking you for the dimensions, I'm asking you how many rows and columns, and that's it. So how many rows does this have? 1 row, and how many columns? 3. So it's a 1 by 3 is how we say that. Okay, rows by columns for number 8, what would it be? 4 by 2. 4 rows, 2 columns. Okay, the next one, 3 by 4. And the last one, 2 by 6. Oh, I thought someone had a question. I told y'all it was like the easiest lesson of the year. Okay, so equal matrices. Matrices can be equal to each other, but everything about them has to be identical as far as the dimensions go. Okay, they might have different elements in them, but two matrices can be equal if their dimensions are the same. And in that case, then each corresponding element will be equal. See what I mean by that. I don't have one on the next page, so let's just make one up out here. Alright, so let's say that I had this 2 by 2, 5x, 11, negative 20. Okay, since it's a 2 by 2, it could only be equal to another 2 by 2. And let's say that I had y there, 7 there, 3z there, and just a negative 20 there. Okay, so let's say that I gave you this sentence, this equation, where I had these two matrices equal. Okay, so they could be equal because their dimensions are the same. Each corresponding element will be equal. So what that means is what's in the first row, first column here has to equal what's in the first row, first column here. So if I say that this has to be equal to this, then y has to equal 5. Okay, then I have this thing, first row, second column, would have to be equal to what's in the first row, second column. So x would equal 7. Sometimes occasionally we use equations like this to solve for variables. Okay, then the last one, let's see, we'll use orange. This is in the second row, first column. It would have to equal what's in the second row, first column. So I would say 11 equals 3z. Divide by 3, and z is 11 thirds. So that's what I mean by the corresponding elements would be equal. Things in the same location would have to be equal if the matrices were equal to each other. Okay, so if I have a row matrix, that just means there's only one row. So an example might be like that. Only has one row to it. So what do you think a column matrix is? Yeah, just one column. So maybe I'll use some variables on this one. Maybe like that. Any idea what a square matrix would be? 2 by 2? 3 by 3, 4 by 4, 5 by 5, just the same number of rows as columns. 2 by 2, 3 by 3, etc. Can I have a 1 by 1? I could. It would just have one number sitting in it, or one element sitting in it, so maybe not very practical. Any idea what a zero matrix is?
Zero.
All zeros. Now, it can have any dimension, so I'm just going to say contains all zeros. I'll make a 2 by 2. Doesn't have to have that dimension, but a zero matrix just has all zeros. Super easy?
Yes.
All right. Okay, so this is as hard as it's going to get today.
Wow.
Matrices can be added or subtracted if and only if they have the same dimensions. Simply add or subtract corresponding elements. Okay, so there are 4 matrices provided here. If I want to find x plus y, I tell you what, let's go underneath each one and list the dimensions first, and then we'll already know which ones are compatible. Okay, this is a what by what? 3 by 2, 3 rows, 2 columns. This one is a 2 by 3. This one, 2 by 3. And this one, 3 by 2. So if I'm going to add or subtract anything, the 3 by 2s can only be added or subtracted together, and the 2 by 3s can only be added or subtracted together. Okay, so is x plus y compatible? Yes. So what I'll do is have a 2 by 3 for my answer, and in the first element, I will just add 24 plus negative 15. What's 24 plus negative 15? I have a whopping 9 right there. And we're going to go across and do the same thing. What is negative 8 plus 29? 21. What is negative 3 plus 17? 14. Go to the second row, do the same thing. Negative 4 plus 9 is 5. 6 plus negative 5 is 1. And last, negative 17 plus negative 2 is, and we are done with that addition. All right, z minus w. Now, you guys know that we make mistakes when we subtract, right? So z subtract w. So let's be careful. The answer will be a 3 by 2. Okay, negative 3 minus negative 1. Use your calculator if you have to. Negative 2. Negative 2 minus 9. Negative 11. Negative 16 minus negative 11. Negative 5. Look at that mental math back there. 0 minus 15. What? 0 minus 15. Negative 15. You got it? 12 minus 8. 4. And 9 minus negative 20. 29. Okay. Don't miss these because you're too proud to get that calculator. Subtract them on the calculator if you need to. Okay, what about w plus x? Can't do it. Okay, the dimensions don't match, so I can't add them. So we say not possible. Okay, x minus y. All right, y'all do that one and then we'll check it. That one can be done. The answer will be a 2 by 3. to check? All right, let's go across and give me your answers. Okay, so going across the first row, what did you get? 39. Okay, keep going over. How much? Okay, next. And bottom row. Good. Next. And good. Question. All right, last thing here. Scalar multiplication. Matrices can be multiplied by a constant, which is called a scalar. In this process called scalar multiplication, each element in the matrix is multiplied by the scalar to produce the new matrix. So if I ask for 3x, that just means take everything in matrix X, and we're using the ones at the top of the page here, and multiply everything by 3. And that's it. So here's X. I'm going to multiply everything by 3. So I think we can either do this in our head or on the calculator. Let's see, 24 times 3 would be, oh, got to push all the buttons there, 72. And keep moving across. 3 times negative 8 is negative 24. 3 times negative 3 is negative 9. And then we're going to do the same thing on the bottom row. Negative 12, 18, and is that negative 51? And that's it. Okay, 3/4 times W. Okay, so we're going to go up, take W, multiply everything by 3/4. If it doesn't become an integer, we'll just leave it as a fraction, okay? All right, so first I will get negative 3/4. I'm going to go down on these here. Negative 11 times 3/4 is just negative 33/4. 8 times 3/4. Now that will simplify to 6. Stop me if you have a question. 9 times 3/4 will be 27/4. 15 times 3/4 will be 45/4. And then negative 20 times 3/4, that should give me negative 15. Question. All right, so 17. Now we're going to combine the addition with the scalar. So I'm going to figure out what negative 5x is, then what 2y is, and then I'll add them together. So first of all, are they compatible? Yes, x and y have the same dimensions, so we can do this problem. So I'm going to find negative 5x first. So 24 times 5, that's going to be a negative 120. Positive 40, y'all stop me if I make a mistake, 15. Then I will have 20, negative 30, and 17 times 5, 85. Okay, then I'm going to add to that. I'm going to take everything in y and multiply it by 2. So negative 30, 58, 34, 18, negative 10, negative 4. And then I'll add those together. Okay, so my answer will be negative 120 plus negative 30 is negative 150. 40 plus 58, 98. 15 plus 34, 49. 20 plus 18, 38. Negative 30 plus negative 10, negative 40. 85 plus negative 4, 81. Good? Okay. 4w minus z. 4w, let's do, are they compatible? Are w and z compatible?
Yeah.
Yes, we were all hoping that they weren't we? 4W. Okay. Negative 4. Negative 44. 32. 9 times 4. Be careful with the subtraction. Check up here when you're done. Are we good? Okay, let's just do 20. I think we've got this, don't you? Should I distribute and multiply y by 1/2 and then x by 1/2 and then subtract them, or subtract and then multiply by 1/2? Okay. Actually, you can do it either way, but I think I would do what you suggested, John. I think I would subtract first, then worry about the 1/2, and then you only worry about the fraction once. They're not compatible? Oh, yeah, they are. Dang. X and Y are. Dang, that would have been fast, wouldn't it?
Sorry.
That's all right. Okay, y minus x. Ooh, negative 15 minus 24. 29 plus 8. 37. 17 plus 3. 9 plus 4. Negative 5 minus 1 is negative 11. And 15. Okay, so I subtracted them. Now I'll deal with the 1/2. So I've got that, it's called a scalar of 1/2. Everything in the matrix gets multiplied by 1/2. If it doesn't simplify, just leave it as a fraction. Okay, check up here when you get yours. Only one of them simplified. So did I lie? Was that the easiest lesson ever? Pretty much, isn't it? Okay, tomorrow what we'll do is learn how to multiply matrices. There's a definite process for that. It's not as easy, but it's still very, I think it's kind of fun. But you know, my sense of fun is a little weird. So that's what we'll do tomorrow. So for the rest of today, I have your 1-page homework on this. And then if you want to keep working on the quiz, you may do that. Okay? Stop this and get those homeworks.